So when you're solving equations, hopefully you've seen some of this before. The idea is to isolate the variable, whatever the variable is. Sometimes the variable is represented more than once within an equation, and you might have to combine terms, but for these problems, we start off slowly and see where things go. If we're going to isolate the variable, we kind of want to perform our order of operations in ways that are dissimilar to the way that we were doing it before. So you think of order of operations, we talked about parentheses, exponents, multiplication, division, addition, subtraction, PEMDAS. When you're solving an equation, you're basically following PEMDAS backwards, right? So the idea being that you'd handle any addition, subtraction first, then multiplication, division, then any exponents and parentheses, right? So my first move here would be to try to get rid of that 2, right? Using the opposite of the operation that's there. So I have a positive 2. I want it to go to 0. So I would subtract a 2. All right, that's going to zero it out. That's also using, I guess, one of the properties that we've been talking about. This is going to give me a result of 0. When I take two numbers that are opposites and add them together and get a result of 0, what property am I working with here? Additive inverse, yeah. Okay, so now that's an illegal move, what I just did, without keeping my equation balanced. So whatever the operation is that I do on one side, I have to do it on the other side, right? So most people just, once you get the hang of this, will just do a cross out of the two opposites and not write the +0 or the 0 itself. But for at least the first problem, I figure, let's do it the old school math teacher sort of way. All right, so that's what the next line would look like. All right, we performed our operation, the 4n just comes down, all right, because we didn't do anything with that. So now I'm looking at 4 equals 4n. All right, that's my next line of work. So 4 and n are connected through multiplication. What operation undoes multiplication? Division. All right, so I'm taking the 4, dividing it by a 4, and that's going to give me a result of 1. We still have the n. We didn't do anything with the n, so that's coming along for the ride. Dividing 4 by 4 to give a result of 1, that's an example of what property? Here it was the additive inverse property. Here it's the multiplicative inverse, right? It's kind of weird, and this is a way of thinking that I'm going to want you before too long to sort of kind of make your own, and that is when you do something like 4 divided by 4, that's the same as 4 times 1/4. Here, I think it's obvious that what you're looking at is the multiplicative inverse. Multiplicative inverse operation, right? The property itself would be 4 times 1/4 equals 1. But these two things are the exact same thing, all right? And that's going to help you to understand how to solve equations that involve fractions, right? So very, very important. It may not seem like it right now. It seems like a waste of time and a waste of energy, but I promise you it'll pay off. All right. The shortcut, of course, just like for addition, you don't actually have to write the 1. You just cross off the 4 and the 4. But I don't feel like you've earned the right to use the cross-off method until you understand why they would cross off in general. All right. Now, I have to perform the same operation to the other side, keep my equation balanced. Gives me a result of 1. So 1 equals 1n, making n equal to 1. All right. The sides of an equation are interchangeable, so I can take whatever is on one side and move it to the other side. So that was my license to switch things around. The other thing is I made the 1n into a 1. What property is evidenced here? 1n becoming a 1. So it's multiplication, so I'll give you the multiplicative part of it. Multiplicative, you're multiplying by a 1. Not inverse. Identity, yeah. Anytime that through whatever operation you're dealing with, anytime the number does not change through that operation, it's an identity. If it's additive identity, it's because you're adding 0. If it's multiplicative identity, it's because you're multiplying by 1. All right. It seems like a waste of time to really talk about these properties until you get to a Regents question in the free response area, part 2, 3, or 4, that says something like, solve the equation by justifying each step using an appropriate property. So we'll talk about that in a minute, but all that stuff that I just kind of hand-waved over, you're going to have to state that explicitly, which means when I do this, I should, if it were that kind of question, I should write additive inverse property next to it. I do this one, multiplicative inverse property. This one we can kind of take for granted, but you never know how picky they're going to be in any given year. So to be safe, I would say 1n becomes 1 through the multiplicative identity property. Right? This is not a me rule. So don't hate me for it. Maybe you don't even hate anyone right now because it hasn't come to a point where you've had to pay the price for it. But to prep for the exam, I'll have to put questions like that on a test. And you'll, in some cases, lose some credit. And that's when you're going to get upset. All right, so just kind of buy in early, and I think you'll be fine. All right, but for now, we'll just go through the equation process without writing the operations. So what's my first move for number 2? Minus 6 to both sides. All right, so we could do the cross-off business here because you know it's going to 0. We're looking at y over 3 equals, what's my right-hand side going to be? Negative 51. All right, we have a division operation here. What's question?
Oh, no, I was gonna...
Oh, next step?
Yeah.
My man. All right, next step would be to do what?
Multiply by 3 on both sides.
Multiply by 3 on both sides. All right, we had a division operation, so we're going to undo that through multiplication. Again, cancel. You know, you could just do your strike through here and leave yourself with the y, because that was the whole point. You multiplied by 3 to get rid of the 3 on the bottom, so you know everything on that side is going to have to go away. And so what's negative 51 times 3? Negative 153.
My calculator comes down.
Freaky Friday. Calculator's just messing with you. It's always a good thing, to have something to blame.
Now it says
It's still the calculator's fault. That's what we're going with. So my son's in 3rd grade, and I'm teaching him how to multiply now.
my calculator's being so annoying.
Is it still doing it?
It's saying like answer and then minus.
Oh, there we go. Finally.
Gotcha.
It's like telling me different things. Like, chill.
So I'm trying to teach my son how to multiply bigger numbers. Math teacher, so I want my kid to be like the shining star in the class. So I take whatever he's learning and try to teach him like the next thing, so that he's always like 1 or 2 steps ahead of the class. And we're up to stuff like this: negative 51 times 3. Yeah, I know. Overachiever. So the negative parts he understands, which is shocking because he's in 3rd grade. But he gets it because I explained it as opposites.
I think I learned multiplication in 3rd grade.
Multiplication is 3rd grade, but not negatives, generally. So when you're multiplying 51 times 3 in your head, you're really looking at the 2 different parts, and this is what Common Core is trying to do, or what they were trying to do with those number bonds and things like that. They're trying to get you to a point where you can multiply in your head. I just don't think they did a good job with it. Did you do number bonds when you were in school? You did Common Core, but you didn't do number bonds? All right, so what you would do, if you looked at a number like 11, the number bond for addition, if you were just looking at addition or you're learning how to add, you would look at this as 10 and 1. The number bond would be made up of these two elements, right? So then multiplication, you have something like 51, you're breaking it up based on the place. So you have a 50 and a 1, right? So it's the same idea through addition. So how do you get to a 51? So then when you're multiplying, and this was the whole point. This is why you learned it that way. It just, I don't think that early on the teachers at that level understood why they were doing it, so they couldn't really convey to you why you were doing it. But the whole point behind thinking of 51 this way was so that when you go to multiply it by 3, you know to take the 50 and multiply it by the 3, and then take the 1 and multiply it by the 3. So 50 times 3 is 150. 1 times 3 is 3. Put them together, you get your 153 that way. Right? All of that number bond stuff was for the purpose of you doing all of this stuff in your head. So once you mastered that, they handed you a calculator and said, forget everything that you learned previously, because now you have a calculator. So you don't need to know it. And it's kind of funny because if you ever get into like an AP math class, it goes the other way, where it's like, okay, so half the exam you're gonna have to do without a calculator at all. And they're like, oh, my weakness is arithmetic. I don't know how to, I can't do complex calculations in my head. So that ends up being a problem. So even in my AP calculus class, I talk about stuff like this. It makes life a little easier. I went over that in my college Calc 3 class over the summer. So that's, if you were to go the traditional route here, you'd end up in pre-calc, senior year. So that would be 3 levels of math after you finish high school. All right, so it'd be your second year into college. I'm still talking about basic arithmetic, mental math, because it makes all the difference. Very exciting stuff. All right, so 2 ways to handle number 3. We have a connector here of multiplication, so I want to disconnect that. So opposite operation would be division. All right, so one way to handle it, if you want, would be to divide both sides by 3/4. Cancels here, but then you got to think about the right-hand side. You got 30 divided by 3/4. So order of operations, is that 30 divided by 3, then by 4, or is that divide the 3 by the 4 first and then divide it by 30? Don't overthink it. It's a division problem. So it's really the same as saying 30 divided by 3/4. How do we divide two numbers when fractions are involved? Multiply by the reciprocal. All right. Keep, change, flip. Keep, change, however you learn. So now I want to multiply a number by a fraction, and assuming that you're not using the calculator. I mean, you will be on a test, but it never hurts to give it a shot in your head first before you go to the calculator. You know, exercise that muscle. Make the 30 into its own fraction. You can try to simplify if you want, but when you're multiplying fractions that are on the same side of an equation, we multiply across. So we'd be looking at 120 over 3, which divides to equal 40. All right. Another approach that you could have taken if you wanted to would be immediately to multiply by the reciprocal, because if you're thinking multiplicative identity, you'd say, I want this to become a 1. If I multiply by 4/3 here, that'll make it into a 1. As long as I multiply by 4/3 over here, it allows you to kind of skip some of this stuff.
Like multiply across, not like.
Instead of cross. Cross multiplication happens when you're dealing with a proportion. So if you have fractions on either side of the equal sign, then you can cross multiply. But if they're on the same side, we do it across. Good question. That's It's a common misconception, so hopefully everybody follows that. If you didn't, then we'll talk at some point. It'll come up again. All right, first move in number 4 would be to do what? Add the 7. I'm going to go blue for those keeping score at home. Got a little cancellation there. What is negative 13 plus 7? Negative 6 equals negative h. All right. Most of the time, especially moving forward, if you're just doing it to scratch out a solution and you don't have to justify your work, you're going to say, well, I got negatives on both sides, so just drop the negatives. But the justification for why we're able to do that is because I'm going to divide both sides by a negative 1. Negative h divided by negative 1 is just a positive h. Negative 6 divided by negative 1 is just a positive 6. And you could write 6 equals h or h equals 6. Doesn't matter what order. I had a teacher back in the day that would take off credit if we didn't write the variable on the left-hand side. I think that teacher's objective was to get the people to not like math, because that's the only justification I can think of for forcing people to write it one way as opposed to another. It's equivalent. H equals 6, 6 equals h, it doesn't matter. Okay. Got some practice here, but this I want to at least do one of them for you. Where's my highlighter?
I see it.
This is the eraser. What is this? Is that supposed to be a highlighter?
No, I like makes the whole screen.
Oh, really? There used to be a highlighter and a pointer. Well, here's the pointer. I'll use my lightsaber pointer. You can go Sith. You can go Wise Jedi, or you can go Jedi Knight. Yeah, but it's the fighting Jedi. Blue is for good swordsman. The green is for Force users. And it's kind of nice. You know, you watch the original trilogy, you can see the transition from Luke using a blue lightsaber to a green lightsaber, and you can see how his attitude changed concurrently with that. All right, so we're going to solve this equation, but be able, I guess be sure, to justify each step with a property of equality. All right, so all those properties that we had, they have their own variations in equality. And so we just have to make a statement justifying why we're doing the things that we're doing. Okay? So, what would be my first move in number 5? What's the first thing you want to get rid of? How about I start with that? Get rid of that 5, right? It's connected through through division, so I just gave you the answer. So we're going to disconnect it by multiplying. All right, so this is the multiplication property of equality. Red. Multiplication property of equality. It's a property that tells us that the equation has the same value if you multiply both sides by the same number. The only exception to that is 0. You can't multiply both sides of an equation by 0. Okay, we'll do an activity later on down the line that justifies why that's the case. All right, so we can now cancel the 5s. Meh and meh. And we'll be left with 2y minus 10 equals 40. Next move. Still writing. Gotcha. Next move. Add a 10, yeah. So So I'm going to add a 10 to both sides. I'm going to go green. Is that visible? Yeah, it's visible enough, right? So cancellation there. We're looking at 2y equals 50. Now, what property did I use? What property of equality? Just what you did, followed by the words property of equality. So what did we just do? We added, yeah. Addition. Property of equality. All right. For your notes, homework, my quizzes, my tests, POE, I know what that means. The regents, they know what it means, but they're going to pretend that they don't know what it means and take off credit. All right. So I recommend that you write the whole thing out, get in the habit, but I also say that with a little caveat that I wouldn't write it out all the time myself, so I don't expect necessarily that you would. All right, next move. Divide by 2. So we get a clean result here, shockingly, not shockingly. Y is equal to 25. What property of equality did I use there? Division, yeah. I'll just write it out. This is the foundation of something that's called a rigorous proof. It's not something that every student enjoys, but the people who enjoy it really enjoy it. They think it's the coolest thing ever. But the people who hate it, like they despise it with every fiber of their being. It's basically, it transcends all branches of math, where not only do you do the thing that you're doing, but you justify it using appropriate properties. In geometry, you'll spend entire units of study on that, where you're proving different relationships exist, like two different triangles are congruent to one another, two different lines have equal length, things like that. But every step that you make, you justify it with a property. In theory, what happens is, we do this enough times now that later on, all of this stuff is just happening in your head. It becomes more intuitive. You start to understand why the things are happening the way they are. And so then you never end up questioning, oh, do I do this or do I do that? Because you have a property to justify your work. All right. We'll do one more, do number 6 together, and then go from there. All right. In number 6, first move. That could be our first move. Sure. Subtract 4 also. You have 2 different ways to go. If you distribute, so just kind of play it out in your mind. Distribute, you're going to have a constant over here, something that doesn't have a variable attached to it, which you can then combine with the 4 before you bring it over to the other side. Perfectly fine. But you could also look at this and say, well, I don't want that 4 there. It's confusing me. It's distracting. If that's the case, then get rid of it. But I heard distribute first, so that's what we're going to do. And it was a great suggestion, so is the other one. No way to go wrong on that. So I'll just draw a little diagram here. When I distribute, what do I get? 4d minus 8. I'll leave everything else the way it is for now. Yeah, then we're going to combine. Okay, so the justification for this was the distributive property. Oh, I almost said properties. Actually, that's not true. I almost spelled property wrong, and I made up an excuse on the fly that I was going to spell something else just to not look foolish. So anyway, distributive property. If you write distributive property of equality, that's fine. But we didn't utilize equality here. We only worked with the expression, so it really is just the distributive property. But if you wrote of equality, nobody's taking off credit. All right. This guy over here can be combined, or these two guys, or gals, I don't know. So my next line would be 8 equals 4D. What's negative 8 plus 4? Negative 4. As far as a justification for that, that's just addition. All right. It's not additive, identity, additive inverse, nothing like that. We just added the two. Combined like terms, if you want to say that. All right. Now this is more like one of the do now problems. So next move would be to do what? Add 4. My justification for that would be what? Outstanding. You could say additive inverse, or you could say addition property of equations, of equality. Either way is going to be fine. All right, so we'll say additive inverse though. I can't write. Or addition POE. All right, next move. And really the last meaningful move is what? Divide by 4. So we got 3 equals D. Final answer. Wonderful. What property justified that? Division property of equality. Or we could say, what's the other possibility? Multiplicative inverse, right? I mean, it's rough when you don't know it, and the exact thing that I'm asking you about is written like right here in full detail. Like it even has the same numbers. It's incredible. Okay, so utilize your resources. So multiplicative inverse. Or division properties of equations. Property of equations. I'll box it. I'll box it in. Oh, I didn't box the other one. That is unfortunate. Going back. Boom. Consistency. All right. If you please. First step.
You subtract. No, you add 15 on both sides.
Add 15x. Now, if you add 15x, that's going to make this a 30x. Is that what we want to do?
You want to subtract 15.
We want to subtract. Our goal is to get rid of that 15x, right? So let's subtract.
Or you could add 9x.
Or you could add 9x. Well, which is nicer? Which is cleaner?
Add 9x.
Add 9x? Okay. And you can combine steps, but I'm going to do it separately, at least for a couple of examples. All right. So we have 24x minus 10 equals 2. All right. What was the property that allowed us to do that? There's two possible answers that we can go with here. Additive inverse. All right. There's another name for that when you're dealing with equations. It kind of simplifies things. It's known as the addition property of equality. All right, you can call it either. All right, I think in this case it probably makes more sense to call it the addition property of equality because just based on the directions, it said which justify with an appropriate property of equality, so that makes a little bit more sense. But if it just says justify each step with some kind of property, then you can go in. Right. Next step. Add 10 to each side. All right, so we're looking at 24x equals 12. And again, that's the same deal, right? Maybe I'll be more specific. Same as above. All right. Last step.
Subtract 24.
Divide. Yeah, its connector is multiplications.
Wrong one.
Opposite operation always. So we get x equals 12 over 24, which is what? 1/2. You can go 0.5 if you want. I don't have a problem with putting answers in decimal form if it's a clean decimal. All right. If it gives you a hideous decimal that you'd have to round, leave it in fraction form. All right. So 1/2 goes to 0.5. That's clean. 1/4, 0.25. That's fine. But then when you have something like, I don't know, let's say 3/8, which I think is 0.375. If you get that and you round it to like 0.38, that would be wrong. All right. What property was at play here? Distributive inverse. Yeah, why not?
Is that a legitimate term?
Not really. It's multiplicative inverse.
Oh, it would be? Okay. Oh, it's 112 or 124.
Boy, hold on. Let me get this over here. I'll explain that one in a sec. Now, you could incorporate division here. As an explanation, you would say division property of equality. All right. So I had this example from before, but it works kind of. I can make a slight adjustment. If you take 24 and divide it by itself, or any number divided by itself, that's the same as multiplying by the reciprocal. So you're looking at 24 divided by 24 being the same as 24 times 1 over 24. Whenever you have two values that multiply to equal 1, what you're looking at are two numbers that are multiplicative inverses of one another. All right? So that allows us to call this operation as the multiplicative inverse operation. However, what you actually did was you divided both sides of an equation by the same number. So we can also think of this as the division property of equality.
So what have we called it here, subtraction?
It's still addition because you're adding a negative number. If you wanted to say the subtraction property of equality, that I wouldn't take off credit for that stuff. Right? So you get x equals 1/2. Now, the calculator technique that I showed you before, it can still give you fractional answers, but you need a little workaround. It's not as simple as the cases where you have a nice whole number answer. So I'll leave calculator approaches for funky answers for another day.
If we put our answer into x equals 0.5, would that be it? Like, would it take points off?
No, that's what I was saying before. If it's a clean decimal, that's fine. It's when it's an ugly decimal that you have to round or something, then leave it as a fraction. And also, any direction that's given on a test or a quiz, that trumps everything else. So if it says put your answer in simplest fraction form and you put a decimal, it doesn't make me happy to take off credit, but I have to, all right, because you didn't follow directions. All right. Ocho. First move.
You multiply y and 7 by 3.
Multiply y and 7 by 3. What property is that?
Distributive.
Distributive property. All right, so we're looking at, as a next step, I'll go in black here. 2y plus 3 equals 21. Jeez Louise. Tell it's Friday. 3y plus 21. I could have salvaged it, but I didn't think it was necessary. All right, next step.
Subtract 3. You saw that.
Yeah, subtract 3 from, yeah, just call it out. I want class to be more of a conversation than overly formal. As long as you're not stepping all over each other, then I think everything's going to be fine. So we're subtracting 3 from both sides. We get 2y equals 3y plus 18. I want to go blue on that, actually. And what property was that play here? Additive inverse, or we could say additive inverse. Okay. Yeah, addition property of equality. The addition PO. Abbreviations are fine for me as long as it's reasonable as to what the abbreviation represents. And especially if I use one, then it's fair game for you to use one. Just be careful on the Regents exam. Abbreviations that we use in class, sometimes the grader either intentionally or unintentionally plays dumb, where they're like, well, I don't know what POE stands for, so -1. You didn't answer the question fully. Right? Sometimes they're just mean people. Yeah, and I'm not allowed to grade your Regents exam, so you can't count on me being like, well, I know what that means. You know, somebody else grading it. All right, next step. Subtract 3y. All right, so same. Oh, jeez. Same as, I'll say same as previous, because above could mean anything, right? All right, so I'm looking at negative y equals 18. Final step. Divide or multiply each side by -1. Gives us y equals negative 18. The justification for that needs to be something other than, well, it's common sense. So you can't write stuff like that on a Regents. They'll destroy your grade for it. Even though you look at it and say, well, it has to be because we're just taking the opposite of each side. So what is my property here?
Distributive.
Not distributive. Distributive, we want parentheses with a sum or a difference inside the parentheses.
Wait,
But you use distributive property in the beginning.
it's the identity one, isn't it?
Oh, you have to do it what ends it.
The identity one?
Yeah, it wouldn't be distributive property because this is an example of what distributive property looks like.
Is it multiplicative identity?
Multiplicative inverse. Or we could say, what do we do to both sides? We divide it, right? So we could say the division property of equality. When you're dividing by any variation of 1 or -1, it's often hard to see that it is in fact an inverse at work. So if you don't see that, you can always think about what operation you're performing and just throw a POE at the end. All right, so what did I do? I divided, division property of equality. What did I do to both sides? I added, addition POE. I subtracted, subtraction POE. All right, so when in doubt, go that route. That rhymed.